Welcome to the GearVR Framework Tutorial Lesson 2, where we learn about the application structure and the scene graph, and where we will write a very simple GearVR application. So our approach is a little bit different than the standard OpenGL application because GearVRF is a framework. Being a framework, it's kind of like the Android framework. It controls the flow of execution. So instead of having complete control over everything that's executed in what order it is, your application instead will respond to events via some callback functions. So it's more of a don't call us, we'll call you model, where the framework calls you and then you do some work and it controls when the work is done and how often. One thing worth noting is that scripts can be attached to scene objects, and they can be written in JavaScript or Lua, as well as having Java components attached to them. So that's how you would do a lot of work in your scene, is to have specific components attached to objects. We'll see this later. Now, the 3D graphics are represented as a scene graph. And what this means is that you have constructed a set of data structures that describe 3D objects, as opposed to making OpenGL calls directly. GearVRF will both do graphics and animation for you, and you will not have to worry about doing these things directly with OpenGL or with the CPU. The application structure is similar to Android in that you would subclass activity. In this case, we subclass GVR activity because it's for GearVRF, and our activity adds a little bit of extra functionality in that it starts up automatically for you the 3D scene and sets up the virtual reality head transforms for you. And we'll give you more detail about that in a bit. So the idea with activity is that you would override on init to start your application. And then if you want to capture touch events, you can override on touch. It comes with an XML settings file that lets you set up all of the VR specific things. The next thing you would do is subclass GVR main. This lets you construct your 3D scene by overriding the onInit function. And your 3D scene contains all of your 3D objects, and this is the meat of your application. Now, every activity has a GVR view manager, and this is what controls the flow of execution, and it makes the OpenGL calls, and it also performs animation. Now, the view manager is orchestrating a system that's written in both Java and C++. So the native part of GearVRF is C++, and it's the part that makes the OpenGL calls. So just to show a little example, the application startup, here's a situation where we are subclassing my activity, subclassing GR activity with my activity, and we're overriding onCreate and onTouch event. And now I'll show you how we would do that in a real Android Studio situation, because we're going to invent tutorial lesson 2 right here. Now that we've done the startup, we can go to the next step, which is setting up the camera rig. Now, the camera rig has a camera for each eye, and it also has a camera in the center. A camera has a background color and a render mask, and these can be set independently for each eye. The camera rig and its children will track the user's head motion. So this is automatically done for you by GearVRF. You don't have to do anything extra to connect it with the head. So in this example, we're going to set the background color for both eyes to white, and we'll attach a textured square to act as a head tracking cursor so that you get to see where your eyes are looking. And this is just an object that is attached as a child under the camera rig, the actual head transform part of the camera rig. Now I will implement the balloon main class that overrides GVR main. This will be a new class, and it's going to set up the camera rig. So here's our new class, and here is the code to set up the camera rig. Okay, and that's a complete application that's just going to show a head tracker attached to the camera rig. In order to see this, you will have to take your Oculus signature file and remember to put that in the assets folder of your application. So that would be in here. You put your Oculus signature file, and that file is what allows your application to run on the phone without the headset. If we don't also add the on-step and on-touch event overrides, we'll get build errors because GVR main requires us to override these because it is abstract. So if we override these, in addition to what we've already done, we should get it to build and produce an application that displays a head tracker that will move when you move the phone or when you wear the headset and move your head. Now, I have a little visor emulator that's going to show what actually happens on the phone. It's going to show a white screen, and this little dot is the head tracking cursor. So this is what you'll see on the phone for just this part of the application. Well, a white background and a head tracking cursor is pretty boring, so we better put some stuff in our scene. In order to do that, we need to make a scene graph. And the scene graph is just a tree of 3D objects. Now, we call GVR scene object as the base of the nodes in the tree. So all of the nodes in the tree are either a GVR scene object or derived from GVR scene object. It has children that are other GVR scene objects, and it also has components that are attached that provide different types of functionality for a scene object. So in the diagram you see here, there's the children, and then here there's the components. And the components are all attached to the scene object, and there's only one type of component per object. So one example of a component is a transform. Every scene object has a 4x4 matrix that transforms it relative to its parent. Another component you find on a lot of scene objects is GVR render data, and that is a component that indicates what you want to render for those things that are visible. Visible objects have a mesh, which has vertices and triangles. It describes a shape in terms of an index triangle mesh. And then it has a GVR material, which contains the material properties that control the appearance of the object in the scene. And then there's another camera rig component that we're already familiar with, and this tracks your head movement. Now, every frame, GearVRF examines this scene graph and converts it into OpenGL calls. Because mobile is not a platform that has got the best graphics performance, you can do about 100 renderable objects before you might not be able to make your frame rate of 60 Hertz. This is just the situation in mobile now. We have some techniques that we are doing underneath in GearVRF to improve this, but in general, about 100 draw calls is your budget for your scene. Now, the scene graph can be constructed programmatically or it can be made from assets. In this lesson, we're going to talk about programmatically making the scene graph. In this example, we are going to texture map a sphere and have that as the environment. And then we're going to put sunlight from above in the sphere. So this is the little thing we're going to try to do. And the viewer is going to be inside the sphere. So the sphere is going to have a nice cube map texture on it that's going to provide a pretty scene for the activities that are going to occur inside the scene. And there's going to be illumination from above. So here we are back in Android Studio, and we're going to add a function that will make the environment for our application. So this is the make environment function, and it's pretty much the code I just talked about. We have our sunlight and we have our textured sphere. And then we want to put the call to make this environment right after we add the head tracking cursor. So we're going to put it right there. And then we're going to build the application. And we'll see what that does on the phone. Let's run our application and see what does it do on the phone. Here's our little phone window, and this is the application running from before, so I'm going to cancel this one and run the new one. And so here is our application running, and you can see the scene that we have mapped onto the sphere, and you can see as I move the phone, the sphere moves because we're looking at a different section of it. So this is what we have so far. We're inside a texture map sphere.